Hi guys. Up next is something called molarity, and it's measuring how concentrated our liquids are. So after today, you should be able to define what molarity is, and then we have a mathematical formula to go along with it. You should be able to calculate moles, liters, or molarity, because that's what's in the formula, and then also explain how to make a solution. So think back to yesterday. Remember that word concentration is the measure of how much solute is dissolved in a given quantity of solvent. Remember, solute is what you add. So remember, think like Kool-Aid. That would be your solute in your solvent, which is water. So what is molarity? In chemistry, it is the number of moles of a solute dissolved in 1 liter of solution. So we got to go back to moles, which means we'll need to break out the periodic table here for a second. And this right here, this definition also gives us our equation. So molarity is moles dissolved in 1 liter, which gives us moles divided by liters. So it's important to know that when we talk about the volume of a solution, it's the total volume. So that includes the stuff we put in and the liquid. I know that's kind of confusing, but think about if you took a pitcher and it had water in it that was exactly 1 liter, and then you added all of your Kool-Aid. So you added the little package, but then you also added sugar. Your water level is going to go up. Now, it's not going to go up by much. Maybe it ends up being like 1.1 liter, but it's still over the 1 liter that you started with. So it's important to note that if you want 1 liter of solution, that it's 1 liter with the liquid, but also with the stuff that you're putting in. So how do we do that? Well, if I want to make a 0.5 molar solution, go back to the definition, that means I have 0.5 moles of something in 1 liter of liquid. So what you do is you add the 0.5 moles of whatever your solute is, whatever your powder, whatever you're mixing, this stuff right here. And you're going to add only half of the amount of water that you need. So if this guy right here is 1 liter of water, you're only going to add to about here, to half. Then you're going to dissolve the solute. You're going to mix it, you're going to stir it, you're going to heat it, whatever you need to do in order to get it to dissolve. And then you fill up the water to that 1 liter mark. So you might have less than 1 liter total water in there, but when it's combined with everything, that's when you get the 1 liter total. So this brings us to what you're actually going to have to do on the test, is you're going to have to do some calculations. So let's say I want you to find the molarity of a solution that contains 0.25 moles of salt in a 0.75 liter solution. So what we don't know is the molarity. We do know how many moles we have, 0.25, and we know our liters. So then we're just going to use our equation. Our equation says that molarity equals the number of moles divided by how many liters we have. And then we can just type this in our calculator. 0.25 divided by 0.75, and we end up with 0.33. Now you can do 2 units for this. You can write moles per liter out, or we can use molarities units, which are a capital M. Now I know capital M and little m look the same, but make sure that it's capitalized, because little m would be meters, and that's definitely not what we're doing right now. So make sure, like if you're writing it on your own, make sure that it's a big M. Like don't make it a little one, or even one of these where it looks big, but it's little. Make it look big. All right, so let's do another one where we're not solving for molarity. All right, so what volume would 1.08 molar solution of potassium iodide would contain that 0.642 moles of potassium iodide? So we have our three variables: molarity, moles, and liters. So we know the molarity this time. We know the moles again, and we're looking for liters. So we plug it in our equation. Remember, our equation is molarity equals the number of moles divided by volume, which is in liters. So you just got to plug that in. So our molarity is 1.08. We know we have 0.642 moles of potassium iodide, and we're looking for liters. Now, there's a bunch of different ways to solve this, but I would suggest doing cross multiplication. It's the easiest. This, we obviously get the 0.642, and then when we multiply these guys together, we get 1.08 times liters, and then we can just divide. Sorry, my pen sucks. I don't know what's going on with it. But then this crosses off, and we end up with 0.594 liters. All right, you guys ready for the hardest one? You'll definitely need a periodic table for some of these. So in this example, I want to know how many grams of calcium bromide are dissolved. That's where we have to do our stoichiometry and a little bit of converting. So I tell you that we're putting it in a 0.455 liter solution, and I tell you what the molar concentration is. So the thing that we have to find, just like the other problems, is the thing we don't know, which is moles. Now, that's not what the question wants us to find, but that's the only unknown that we have, because remember, we have molarity equals number of moles over volume in liters. So we can find moles, and then we already know how to convert moles to grams. So let's plug in what we know. Sorry, my stuff's in the way. So erase this. Okay, so then we can do a little quick math. I would cross multiply again, and when you cross multiply those two together, you'll end up with how many moles you have. So moles equal 0.18. Now, if the problem asks for how many moles, we would be done. But unfortunately, it doesn't. It asks for grams. So what we need to do is figure out its molar mass. So you would break out your periodic table, and we would figure out what this number is up here. So remember, that means we need to find the mass of calcium and the mass of bromine and multiply that by 2. So calcium is about 40.08, and calcium is about 79.9. But remember, we got 2 of them. So if we add and multiply those together, we get 199.88 grams per mole. So remember, that's the number that's going to go right here. Now, our moles of this calcium bromide would cross each other off, and we're left with grams, which is what the problem asks us. So we end up with 36 grams of calcium bromide. Now, this is actually super useful information, because if you want to get something to the right concentration, you have to know how much of your solid to add to the liquid. If you guys have ever looked at concentrated substances like hydrogen or hydrochloric acid, it'll have like 1 molar of hydrochloric acid, which is pretty diluted, versus like 3 molar hydrochloric acid. That is extremely dangerous, but you need to know how much to add to that in order to make it work, which is why we have calculations like this. So right now I want you guys to work on worksheet 2 that goes along with this stuff, but also because of our awesome discussion yesterday, we didn't have time to work on worksheet number 1 either. So you have both of those that you can work on for the rest of class period. If you have any questions, make sure you write them down and I can answer them tomorrow. Have a good day, guys.